Right, got a fresh cup of coffee. Now it is time for more LeetCode. Alright, so we are continuing our path on depth first search. We're focusing on that, trying to understand it, get good at it. Now, best way to do it, randomized medium. So close my eyes, and then we're going to pick a medium. Closest medium is this one, longest Univalue Path. Let's do it. All right, let me minimize myself. There we are. Okay, number 687, longest Univalue Path. Given the root of a binary tree, return the length of the longest path, where each node in the path has the same value. The path may or may not pass through the root. The length of the path between two nodes is represented by the number of edges between them. Okay, so here we see that there is a path from 5 to 5 to 5, and now this has a length of, I guess, 2, because the length of the path between the nodes is represented by the number of edges. So there's one edge right here, and there's one edge right here. So there's two, a length of 2. All right. So here's an example. Oh, okay. So it's not only that we can go in one direction, it can be up through a node and have kind of like that arching where it's okay, so conceptually speaking, this question is easy to understand. Not entirely sure how I will accomplish it. I know that I will probably need some variable to keep track of the current longest path. So current long equals 0. Okay. So the current longest, and then I know that I will also need to traverse the tree, so traverse and then node. Okay. I know that the base case for tree traversal is once we've arrived to nothing. So if not node, return. Okay. Now, how am I going to actually keep track as I go down, starting here? And now I need some way to see. I'm going to try to come here and then figure out if this is a path. Now I'm seeing that this is 5 and this is 4, so therefore I'm going to say that this is not a path. So I might do something where as I'm traversing down, I say, yes, you are continuing this path. Let me kind of explain what I mean here. So like is path and then current length, which is different than current longest. Okay. And then what I can do is kind of like this. So if node dot left equals node dot val, So node dot left dot val equals, then what I need to do is increment, or I need to pass in true as I go in. So, all right, what I'm trying to do is as I go down, when I do this recursive call down, I want to say, no, you are not part of my 5 path. So I'm going to break this is path, and I'm going to set this current length equal to 0. But then once I come here and I see, okay, this value is equal to this value, as I do this loop down, I want to say, yes, you are part of my path. And then I say, okay, yes, you still are part of my path. And then I'm going to increment this current length. So each time I come down, current length is added to 1. Okay. But that I don't think works here, because so I'm going to come here, I'm going to see that this is part of my path. So path, or is path, will be true, and then length is going to be 1. Okay. Nothing, nothing. Then when I pop back up, current length is actually going to go back to 0. So I don't necessarily think that I can have this current length within the recursive call. I think I might need to do current length equals 0 and then update that based off of if it's part of the path. So if it's not the node, okay. So I'm going to take this away. Now the only thing I care about is if it's part of the path. So I come down here, it is part of the path. I come here, and then let's say that there was a 2 here. So then it's going to be false. It's going to, am I going to break current length though? Because if there was a 2 here, I'm going to set is path equal to false, and then I'm going to then have current length back equal to 0. Then it comes up here, and now I want current path to be equal to 1. I want it to continue to be equal to 1, and then I want it to be equal to 2. If node.left.value equals, then maybe I can do true. In this case, else traverse node.left false. So then I'll comment my thing like well, this is almost like self-commenting right here. This is the one that I need to comment. This is the else case will be left value is different than current node's value. Okay. Now I need to do the same thing for the right. So copy and paste this for right. Right and right here. Right. Okay, so trying to think about how to keep this current length updated, but then I can break it. Maybe actually I do have current length passed in. Maybe I do have current length passed in. And then if I hit one of the cases, like if I hit this left case, then I kind of like store the value. So my current path length equals current length. Okay. What are the implications of actually doing this? Good thing I have 2 cups of coffee. Double the energy. Okay. What do I want to do? I want to keep track of. So I come here, current length is going to be 0, then I want current length equal to 1, and then I want current length equal to 2. So each time I recurse down, I want my okay. What am I doing? What am I doing? Current length is now, I'm saving it in a secondary variable that I'm passing in something else, and okay, think what was the fundamental problem which I had which caused me to need to think about a solution similar to this. The problem was I come down here, I add 1 to the current length path. But then when I pop up from my left, this value is now decremented. So I lost that value, and then I come down here. Actually, it was right here. Then I come down here, and I want it to be this current path plus this one, and it might even go down here. So all of this and all of that. All of this, and then if this had children that followed the path. So do I need to kind of like okay, so for each node, one layer down. So this is path. This variable grants me what? It grants me information, knowledge about my parent node. It grants me the information that my current node has a connection to the parent, and that connection meaning that our value is the same. So we are part of I is the current node and part of the parent connection. I also have access to information of my children by doing like node.left.val, so I can check my child's value, and so I have both information to my parents' value and my children's value. Okay. So I am my current node. Right now I'm trying to imagine that I'm this one. Right here. I have access to that I'm not part of this pathway. Does this even help me? Do I need to know my parent? I think I do, because I need to figure out if I need to break it, right? Like if or do I not? Because if I do the recursive call and so let's say that I am currently 5 right now, and I'm going down, I can just add, I look at this node and say, oh, I'm not part of, or my child is not part of my path. I'm going to update its current length to be 0. I'm going to update its current length to be 0, and now I'm 4. Okay, now I'm going to see my current length is 0, and now I'm going to try to traverse left, and I'm going to pass in 0 because I know that this value is not equal to my value. I don't care about my parents' value. I do have access to my child, my left child's value. So I'm going to pass in 0 because I know that I'm not I know that I am not part of a path with my left child because I can see that value. So I pass in 0, and then I come back up, and now I have what information? So first off, I know that I am not connected, so therefore I don't want to add this value's length So let's say that there was another 1 right here. And now this value is going to have a current length of 1. But at here, I don't want to continue the path because this one isn't part of that path. So I don't think I need this is path because I don't care about the parent. Do I need access to the child node's longest path? In this case, what do? I pass in pass in 1 as the length. So current length is going to be 1. Current length is going to be 1. And then I pop back up. And I say what? I say I am part of this connection, and therefore I am going to continue this one here. Okay. I like problems like these, because at least in this one I kind of have some path to go forward with. I remember maybe like 3 days ago I was doing some problems and it was just like I had zero idea how to even take a step forward. This one, I have no idea what I'm doing, but at least I'm kind of like, I feel like I'm lost in a dark forest and I'm stumbling over things. I'm trying to find my way. I'm eyes closed, searching through, feeling my way through things. But I am able to kind of make progress, understand a little bit of what I'm doing. The other one, it was just like I was out in the ether. I had no idea what was going on. I was what? This one, at least I'm kind of, oh, it's okay. I think this object is this. Okay, this is a tree over here. Oh, that's a tiger. Oh, avoid that one. What's this? This is oh, that's a snake. Kind of like that. Anyways, I should stop making nonsense and continue with the problem. so I have this value here. I pass it up to, do I pass it up? Do I need to pass up that? I guess I would have to pass up my current length. So let me just, I don't know, let me just start over like that. Okay, so I think will have to left node length equals, and then traverse node dot left, and then current length is going to be, let's see, I will need to kind of, so I need to check if left node is part of chain. So if node dot val equals node dot left dot val, then we will traverse and add our current length to be +1. Okay, so now this is going to be 0. Current length is going to be 0. Then I add 1 here. And then let's just say I do another one and I add 2 here. So 2. I need to come up. I need to retain this 2 value. Which will be, I'm going to try to store it in this left node length. Then I need to come here and continue to store that value. And then I need to add here. So else left node length equals 0, because I don't care, it's not part of the chain. So traverse node dot left, and current length is 0. Okay, so now I need to go right. So if node dot val equals node dot right dot val, then I need to traverse node dot right and left node length, maybe? Or the highest of I have no idea what I'm doing. If length is higher than left node length, val equals current length, else val equals left node length. What I'm trying to do with this statement is say, like, okay, if I'm passed in, if I have this chain of fives and the current length is no, but I'm at this 5. I just got passed in 2 because that's the length. So 2. I'm here. I just got passed in. I recursed down. I saw, oh, there is. So let's just pretend that these are connected, this 5 and this 1. So I recursed down here. I sent current length equal to 0 down here. So I'm at 0. Okay. And then I come here. I do this. And then I come up here, I return back, and my left node length is still equal to 0 because I'm not part of the chain. So now I want to keep my value equal to 2 if there's another value here which is equal to 5. So I want to pass in 1, 2, and then 3. I want to pass in 3. So if this is the case, I want to pass in highest value plus 1. Otherwise, else I want to traverse and node.right, and I want to pass in 0 as the current length. Okay, now when do I do the check for this one? So I need to eventually update that. So non-local current longest. Okay, and now if current longest is less than current length, then current longest equals current length. Is that the place to do it? I don't know. I don't know if this is the place to do it. I feel like, especially with these problems, you do need to have a systematic way of, like, okay, pre-order traversal, you process the node before you, or immediately when you get there. Post-order, right? Like, you have to know when you're processing something and what process means. And in this case, I feel like I'm kind of just like randomly, oh, I changed this value, I update this, I return this one. I'm doing like 20 different things in this recursive function, and that's normally not a good way of recursing. That's usually fraught with perils. Okay. So I don't know if this is right. I don't know at all. idea. I have no idea. And then I come down here. So I'm right here. My length is 0. This does not satisfy. Then I come here. My length is now 1. And I immediately run this function. So it's like pre-order, right? Yeah, that's pre-order. So then I change current longest length to be equal to 1, which is correct. That's how we're doing it. Length is equal to 1. So now I then do this. I look and I see my child, and it is this is on the right. So I look at that and I increment highest value by 1. So now it's 2. And now I'm at this node, and I immediately update current longest to be equal to 2. Then I say no and no, and then I pop back up to here, and then I pop back up to here, and each time I do that, I need to be returning highest value. No, I'm not returning highest value, because if there's a path this way, if there's like an arc this way, and this is a 4, and this is a 4, I can't go like this. I can't go, here's a path, and then like that. I have to choose like this. Trying to drink as much coffee as I can, so I might be able to solve this, but I don't know if I'm going to be able to solve this one. I might have to go, and we might have to go look at Copilot to see how it suggests doing it, and then do our autopsy, try to learn what we can from this problem, try to analyze the problem, try to figure out how they did it, and how we can avoid the problem in the future. That way, if we see something similar to this, we'll know how to address it. But I'm going to take a few seconds and then see if I can collect myself, and then see if I can figure out how to do it. Otherwise, we'll probably have to go to Copilot. So recursing down. As I'm recursing down, but then I come back up, and I lose that value. So I don't. Yeah, I'm not seeing how to do it. Where is my Copilot? Here we go. Okay. Come on. Yes, I'm a human. Alright. going? Is that part? Okay, hold on. Let me. Here we go. 6, 8, 7. Okay. So, the goal is to find the longest path in a binary tree where all nodes on the path have the same value. This path can pass through any nodes, not necessarily through the root. So approach, we're using a depth first search, which makes sense because we are part of the depth first search section. Okay. Tracking path length. For each node, check its left and right children to see if they have the same value as the current node. Yep. So that's what I was doing. I have access to both children. Okay. Oof. If a child has the same value, extend the path length by including the child. Okay. Recursively calculate the longest univalue path for the left and right subtrees. Okay, while returning from the recursion, calculate the length of the path through the current node and update the maximum path length of the longest seen so far. So just based off of its explanation, I'm not immediately, like, there's no light bulb coming on and because it's kind of like what I was thinking about doing, but I have no idea how to actually implement it in code. As I was saying, like, conceptually, the problem is easy to understand what I'm supposed to be doing. I just can't figure out how. Okay, handling edges. The length of the path between two nodes is represented by the number of edges. Ensure to track the edges rather than the nodes. Okay, updating the global maximum. Maintain a global variable to store maximum path length found during the traversal. Oh, it doesn't even show me the code. Okay. Max length, a global variable. Yeah. I think I'm just gonna have to ask for the code because I don't. Yeah. Okay. So, all right. Now it's time for the autopsy to figure out like what we did wrong, how this code is working, and then what we can do to kind of move forward such that if we come into a problem similar to this again, we don't crash and burn. So, let's try to learn what we can. So we have this function here, depth first search. This is kind of our helper function. I called it traverse here. So traverse. And then we have this local or this non-local max length, okay? Return if not node. And then we're returning 0. So okay. Recursively find the longest path in the left and right subtree. So I'm going to go down and I'm going to see, let's say that there was, this is 4 and this is 4. So I come down here and I see that there's a longest path which is 2 right here, so this edge and this edge. So left length is going to be 2, right? Okay, maybe. And then right is going to be 2. Initialize paths through the current node. Left path, right path equals 0. Okay. So check if the left child has the same value. So if node.left and node.left.val equals node.val. Okay, so they're checking if the left node even exists, because if you do node.left.val, you're going to be dereferencing a null pointer, and we don't want that. Okay, so you have to do this check, and then you do an ANDed operation. Okay. So this is the important part right here. So if the value of your left child is equal to the value that you have, then left path, which is equal to 0, is now left length plus 1. But how does that capture the case where, let's say that let's say this is 4 and this is 4. Okay. So I come down here and I will recurse, and I get length is 1 and then length is 2 here. I don't want to capture that 2 and put it here, because I can't do 3 and then 4. It's 1, 2, 3. I can't add this edge in the path. Check if the right child has the same value. So we're doing the same thing here for the right length. Update the global. Okay, so that's fine. That's whatever. And then this left path and right path. I feel like this is the line of code that kind of alleviates that problem that I'm having between here and here, or here and here. Left path. Man. Okay, so I start here. I recurse down here. I recurse down here. I attempt to recurse down here. Get blocked. I attempt to recurse down here. Get blocked. I am right here. I set left path equal to right path equal to 0. Then what do? I check if I have a left. I don't. I check if I have a right. I don't. So then I take max of max length. So then I just update the max length, which is currently 0 and 0, 0. Okay. Then I return the max of 0 and 0, so then I come back up here. Now I just finished this line of code. So then I try, and this left length returned 0. So now I try to go right. Okay, so now I'm here. Left and right path is 0. I see if I have a left node. I don't. I see if I have a right node. I don't. I update the max length to be 0 still. And then I return 0. 0 and 0. So I return up here. Now I'm here. So left length is 0. Right length is 0. Okay. Now I come here. Left path and right path are 0. So I check if I have a left node. I do. I check if my left node value is equal to my current value. It is. So I take this 0, this left path, and increment it by 1. Okay. So now left path is 1. Then I do the same thing. I check if I have a right node. I do. I check if the right node's value is the same as mine. It is. So I increment right length by 1. So now right path is 1. Then I update the max length to be either it's the current max length or this path right here. So this is left plus right path, which is 2. Yes. So max length is updated to 2, so that's where that's kind of coming in. Then I return. So I've updated the max length. Now I'm returning back up to here. Oh, I see. Here we go. Yep. So if this, I'm just returning one path, either the left path, which means here and all of its children, or this path and all of its, okay, so I'm not going to add this entire thing. That was checked right here. What I am going to do is I'm going to say, okay, the longest path along the left side is this. Whoops. Is this. The longest path along the right side is this. Return the maximum, so return whichever path is the longest, and then from back up here, if you are the same, you can continue on that journey. Okay, so I understand the code. I think this one is another instance where I'm going to have to kind of take some time to digest it. Look at this solution, try to understand the solution, try to map the solution to the actual visualization, and move forward with improving my skills. So thank you for watching this video. Too bad we weren't able to solve this problem on our own. We had to go to Copilot to try to figure it out, but as I said, like, just study this solution, and hopefully we will get better next time. Anyways, so if you like this video, go ahead and subscribe. My name is Timothy Lee Grant, and I will see you guys in the next video. So keep doing LeetCode. All right, bye everyone.